and welcome to ActiveMQ Classic Essentials. I'm Heath Kesler, and today we're going to go over a lab that demonstrates how to set up your brokers in a high availability scenario. So without further ado, let's get after it. All right, so now what we're going to do is we're going to take a look at a simple project. We're going to take a look at the Docker Compose. I did use ChatGPT to generate this. It didn't do a very good job. It actually kind of messed up a little bit. But because I know how this is set up, I was able to get it working with very little effort. But let's take a look at the Docker Compose first. So what we have is broker 1, broker 2. One is going to be a primary, one is going to be a secondary. Well, the way they're named right now is broker 1 and broker 2. So broker 1, we've got this ActiveMQ, which is going to come from this XML, which I'll show you in just a minute. And then we have the ActiveMQ for broker 2, which comes from this file. You'll notice that they're pretty much exactly the same. The other piece is the data lock. So this is the extremely important piece. They have to be able to point to the same directory location. In a more enterprise scenario, maybe a SAN, or at least some place where they can at least obtain lock. So in this scenario, we're just going to use a local. That's pretty much it. The ports, we have 61616 on the box, but that's going to be exposed as 61616 here, whereas broker 2 is going to be set up as 61616 local, 61617 as the exposed on my machine. So when we're connecting, you'll see the connection strings. You'll see that we have a failover that goes from 61616 to 61617. So what that means is that our clients will basically set up to either attach to one or the other, depends on which one is active. So when we fire up these two brokers in Docker Compose, you'll see which one comes up first. So let's just go ahead and give that a try first. So let's go ahead, Docker Compose up, and let's see what we get. All right, so we have one, looks like broker 2 is the one that started, which means broker 1 must be in a wait state. So let's go see what it looks like on Docker Desktop. All right, so it said broker 2 came up. Let's take a look. From a log statement, yep, connector open wire started, so it looks like broker 2 is the active one. So let's go back and take a look at broker 1. We should see that it's in a wait state. Yep. Is locked by another server, so it's waiting. It's just sitting there pinging periodically to wait and see if a lock becomes available. Great. Okay, so we've got our high availability scenario. Pretty simple, right? So again, the important piece is this lock, and you'll notice that the volume is locked down here. So this is how they're trying to attach to the same file location. Whichever one gets locked is the active one. So that's the important piece. So now let's go take what we want to do is kind of run some data through this and kind of see how it works, right? Well, before we do that, I have one more thing. Let's take a look at the XML. It's fairly simple. In this case, we're just defining, here's the KahaDB, here's the data directory for the KahaDB. This is the data directory that's getting the lock, where the file lock is happening. The rest of it is just open wire, transport protocol. That's pretty much it. The next important piece is going to be our failover. So in our Spring configuration, we have an ActiveMQ broker URL, and this is what gets fed to the Camel component. So you'll notice here we have a failover protocol, and we've got the 61617 and 61616. Again, doesn't matter what order it's in, because we're just going to attach to whichever one is active. And that'll be important because we'll run it once, and then we'll stop one, we'll see the failover, and then we'll run it again. You'll see that nothing is broken. It continues to function as it should. So let's take a look, and let's kick this off. So if we do this, we should have and clean install. There we go. Let's run this. What we should see is it pick up, grab a file. Oh, of course we get an error. Why? Let's see. Oh, gotta set it up for Java 21. Duh. All right. So let's clear, get a nice clean. All right. So let's go ahead and run this. Boom. All right, so what we should see is it pick up the file, and there we go. We got the messages were picked up and sent through. So you can see it, and then it was receiving the order. So just so that you guys can kind of understand what's happening here, we're picking up from a file. We're reading the file, as we can see right there. That's this one right here. And then we log out, reading the file header, and then producer. So here we go. We have the producer there. We send to an ActiveMQ, and then we pick up off the ActiveMQ and we receive it from a consumer standpoint. So here you can see the producer and the consumer getting utilized. John Doe. So, you know, there's the producing of the record, there's the consuming of the record. Fairly simple and straightforward. So now what we want to do is be a little more fancy. So what we're going to do is this, we need to, let's go ahead and stop the route. And what we're going to do is we're just going to go ahead and we're going to stop broker 1. So what we should see now, once that stops, we'll see this one will become active. So in a minute, the lock will be released on the file. This one sits there and pings periodically. So depending on how long it's taking to ping will depend on how long it takes to reinitialize as the new primary. So there it goes. Okay, so it started up. Again, store limit, boom, it's now the active and started. So now broker 1 is the one that's acting. So let's go ahead and run this again, and we should see no problem here. To be a little more fun about this, what we'll do is we can actually set this up to do a slow burn so you can see it happen real time, and we'll do that in just a minute. So there we go. You know, ran without a problem. Again, this initialized the connection, so that's a little different scenario. We want to do it where we're not stopping the process at all. So let me go ahead and make an update to the router. And what we want to do is we will add in a timer to slow this down a little bit so that I have time to go in there and actually shut things down and restart them. So let's add a few more records. 1 to the orders. And I'll double it. We'll triple it. There we go. We got a lot of records in there. A lot of duplication. I'm not going to be too picky about it. Okay, now that we've gone ahead and added some extra records, I want to slow it down a little bit more so that we have the opportunity to actually see this real time. So I'm going to throttle this one message, and we want a time period of, let's say, 5 seconds. That should be enough to give us a little bit. You know what? That might be a little long. Let's do 2 seconds. That should be plenty. Now that we have that configured, let's go ahead and rerun this. Actually, real quick, let's go ahead and just take a look at our broker setup, make sure everything's still running. So broker 1 looks like it's the active, and that would mean that broker 2 is the lock service. This is the secondary. So good. We know broker 1 is the one that's active. So let's come back here. Let's just go ahead and stop at current route, and then let's go ahead and let's run it with the throttle on. This will give us time now to be able to watch it. What did we get for an error here? What was this? Oh, it failed to make a connection, and that's fine. So right now it's chunking through. Let's go ahead and real quick, let's go ahead and stop the active one, which is broker 1. So let's go ahead and stop that. What that means is broker 2 should now become the active. It's still in a wait state, so let's see what happens over here. Okay, so in that point we saw that it failed to connect to the 61616. Here we got an error message that says that it failed to connect, and boom, it reconnected, successfully reconnected, as we can see here. And from that point on, it continued functioning again with no interaction. That's the beauty of the HA brokers. So let's just take a look at what happened over here. As you can see in the logs, it went ahead and started after being in a wait state, locked for another server, and then once it got the lock, then it started up, initialized the connections, and now we can come back over here and we can restart broker 1, and it'll come up as a secondary. We don't have to restart or reset anything at all. It just comes up, and now broker 1 will sit in a wait state as a secondary and wait for lock. That's the beauty of the way HA works within ActiveMQ. It's a beautiful thing. So now if we come back here, the functionality just keeps chugging along. That's the beauty part. So, just to complete this thought, now that broker 1 is waiting, let's go to broker 2. And let's stop broker 2. And now broker 1 should become the active. So if we sit here and we watch this go through, did I already chunk through all my messages? I probably did. Nope, it stopped. And let's see, I might have gotten through the messages. I'm not 100% sure, but we'll take a look here. We'll know because it'll reinstantiate the connection. Okay, yeah, we didn't have any more messages left to work with. But as you can see, it reestablished the connection back to 61616. The original failure was on 61617 when it connected. So you can see it's flipping back and forth between the two. So yeah, that's about it. I hope you found this informative. If you did, like and subscribe, and we'll catch you on the next one. Thanks.